All right, we're going to continue with chapter P, section 2. This lesson is going to be on negative exponents and dividing exponential expressions with the same base. All right, so anytime you see a negative exponent, that is not considered simplified, so we need to simplify it by turning it into a positive exponent. And to do that, you either move it from the numerator to the denominator or the denominator to the numerator. So if I have something like this, a to the negative n, I always like to write over 1 if it's not already a fraction. I circle my base, and that is what I'm moving. All right, so if I have a to the negative n, I'm going to draw that over 1 and change its position and turn it into a positive exponent. If I have 1 over a to the negative n, it's already a fraction. I don't need to make it a fraction. So then this is going to move up top to a to the positive n. All right, now, when you're dividing exponential expressions with the same base, you subtract the exponents. So just like when you multiply, you add. When you divide, you subtract. So if I have a to the m over a to the n, you just subtract a to the m minus n. So take something like x to the 5th over x to the 2nd, for example. Right? What is this the same as saying? Well, this is the same as saying x times itself 5 times. X squared is the same as saying x times itself 2 times. Now, when you go to cancel out common factors, you're going to end up with some leftover x's, right? 3 of them. And it's just going to be 3 that are left over when you do 5 minus 2, right? So same exact steps. Similarly, if I had something like x squared over x to the 5th, right? So what happens when I change positions? Right, I can still expand it, and I can still cancel things out. I still have 3 x's left over, but this time they're on the bottom. Right, nothing is left on top, so I'm going to leave a 1 on top. All right, so think about it, right? If I have more of that factor on the top, then I should expect my leftovers to be on top. If I have more of that factor on the bottom, I should expect them to be on the bottom like this. All right, or similarly, you could have done your rule of exponents and done x to the 2 minus 5, and I've gotten x to the negative 3, and then did your rule, right? Write it over 1 and move it to the bottom and make it positive, and you still would have gotten this same answer. All right, so doing some examples, something like 4 to the negative 2. Again, I'm always going to write this over 1 if it's not already. Circle your base and move it to the bottom. So this is going to become 1 over 4 to the positive 2. And then 4 to the positive 2 is just going to be 1 over 16. Right, super easy. Something like x to the negative 3, also, right? Just write it over 1. Circle your base, move it to the bottom. This is going to be 1 over x to the positive 3. All right, and something like number 3, think about what is the base here. The base isn't 2x, the base is just the x. All right, so I'm going to write this over 1, and I'm just going to move the x to the bottom. The 2 is going to stay on top, so it's going to be 2 over x to the 4th. And there's nothing more you can do to that. That is your final answer. If you wanted to move the 2 with it, you would just need parentheses, just to indicate that that entire thing is your base, and that 2 is going down with it. But if you don't see that, you can't assume that's the case. So just the x is your base. All right. Something like this one, a couple different things that you could do. If your base is a fraction, what I typically will do is I'll switch the top and the bottom, and I'll change the sign of the exponent. So this is going to become 5 over 2 to the positive 3. And you can still use the rule that we talked about in the previous lesson. Distribute that exponent to the top and the bottom, so it's going to be 5 to the 3rd over 2 to the 3rd, so 125 over 8. If you didn't do that, and let's say from the beginning you decided to distribute that exponent, you would still get the same answer, right? So it's just a matter of personal preference, whatever you want to do. If I have 2 to the negative 3 over 5 to the negative 3, I would still take those bases and switch their places. And then that would still end up with 5 to the positive 3, 2 to the positive 3, right? So 125 over 8, right? No matter which way you do it, all right? Now, if you look at 5 and 6, right, I stressed it in the previous lesson, what are the difference between those two problems? Hopefully you notice it's the the parentheses. In number 5, that one has parentheses, so your base is this entire thing, that -4. So when I draw the line and write it over 1, I'm taking this entire thing and I'm moving it down to the bottom. So this is going to be 1 over -4 to the positive 2. And -4 times -4 is positive 16, so this answer is 1 over 16. But if you look at number 6, I can write the over 1, but my base is not -4, it is just the positive 4. That means that negative is going to stay on top as a -1 over 4 to the positive 2. Right, so the negative out front is not attached to that 4. I can't assume that it is unless it has parentheses. So then this is going to be -1 over positive 16, right, something like that. So important that you understand the difference between the two. All right, keep going with some examples. All right, so something like number 7, same exact idea. I can write the over 1, circle whatever has that negative exponent. In this case, it's just the y. It's not the xy, it's just the y. So that means x is going to stay on top and y is going to move to the bottom with a positive exponent. All right. Try the same thing. Whoa, I'm sorry. The next one's different. But let's try the same thing with number 9, right? Before I do 8, let's do 9. I'm still going to draw that over 1. I don't see any fractions, so I'm going to write over 1. And I'm going to circle everything that's going to move to the bottom. So x is a base of a negative exponent, and z is a base of a negative exponent. So these are going to move to the bottom. 4 and y are going to stay on top. Those do not have negative exponents. So 4y squared is on top, x to the positive 3, z to the positive 4. Move to the bottom. All right? Now, when you're dividing, again, we had mentioned that you can subtract the exponents, right? But if you have coefficients, same thing when you're multiplying. You're going to do coefficient with coefficient, variable with a variable. So it looks like 4 and 16, we can simplify. That's going to get you 1 over 4. And x to the third and x to the fourth, you might be able to do this without having to write a lot of work. You maybe won't have to write x to the 3 minus 4 and x to the -1, and then move that x to the -1 to the bottom. Maybe you can do it without having to write that work. And if you can, that's fine. But the more work you write on a test or a quiz, the more potential partial credit that I would be able to give you if you make a mistake along the way. So maybe you're looking at this and you can see that if I have 3 x's on top and 4 on the bottom, then 3 of them are going to cancel out and you're left with 1 on the bottom. That's fine, right? If you can think of it like that, then that's fine. But try to show your work when applicable. All right, so let's look at the next one, number 10. Again, coefficient with the coefficient, but I only have one coefficient and it's on top, so I'm going to leave it alone. You have options here. You can either move your negative exponents. So let me try it that way and then I'll show you the other way. So I can either move my negative exponents right away. Doing that is going to get me 3y to the fourth, y to the third, and x to the fourth, x squared. And now that I'm multiplying with the same base on the top and on the bottom, I'm going to add those exponents, just like we talked about in the previous lesson. And so you end up with this as your final answer. All right. If you chose to do your division rule, you still would get the same answer, right? Let's say I did 3x to the -2 minus 4, right? Maybe you know that when you divide, you subtract the exponents, right? And I did y to the 4 minus -3. That becomes a big plus. Then what you get is 3x to the -6, y to the 7th. I have a negative exponent, so I'm going to draw that over 1 and move that -6 to the bottom. So then I end up with 3y to the 7th over x to the 6th, right? Same exact answer, I just did it a different way. You're going to do the way that you feel most comfortable with. It doesn't matter which way you do as long as you don't break any rules of math. All right, so doing some more examples. Something like number 11. You get a number expression out of it. So I'm going to do 5 to the 7. I'm sorry, 5 to the 9 minus 7, so 5 to the second. And 5 to the second is just 5 times 5, so 25. Something like that, you should be able to simplify. Now, something like 12, it's a variable expression. All I'm going to do is subtract the exponents. X to the 14 minus 10 equals x to the 4th. Something like 13, you're going to do the same thing. This is going to be x to the 10 minus 14. So x to the negative 4. Can't have a negative exponent, so I'm going to write over 1, circle that, and move it to the bottom. This is going to get me 1 over x to the positive 4. All right, so notice that in 12 and 13, you have the exact same expressions, just their flipped positions. The order does matter, and you should be mindful. If there's a bigger amount of that factor on the top, your final answer is going to be on the top. In number 13, you had more of that factor on the bottom, so your final answer is going to show up in the bottom. All right. Something like number 14, again, you can either choose to move this negative exponent to the top, or you can just do your rule of division, right? So 5 minus negative 3 is going to get you a 5 plus 3. So 7 to the 5 plus 3, so 8. Now, this is something that I don't expect you to be able to do without a calculator. I can leave it alone like this, right? I don't expect you to do 7 times itself 8 times. Right. So let's keep going with the next one. Again, coefficient with the coefficient is going to get you can divide the top and the bottom by 5. So I'm going to get a 3 on top, a 1 on the bottom. Right, divide them both by 5. And again, you have an option. You can either move the negative exponents to their appropriate position, and we get x to the 8th, x to the 4th. And then subtract the exponents, so I get 3x to the 8 minus 4 over 1. So 3x to the 4th over 1. Anything over 1 is itself, so I don't need to write it. Whoa. All right, something like that. If you chose to do it the other way, maybe you did 3x to the negative 4 minus negative 8, you would have gotten the same answer, right? You get 3x to the 4. All right, minus a negative is plus. All right. Now, if you look at 16, the same exact thing, right? I can do 15 and 25, divide them both by 5, I get 3 over 5. And then again, you can either make those negative exponents a positive, or you can just use your division rule. I'm just going to use the division rule. So I get a to the negative 5 minus negative 2 over, I get b to the negative 1 minus 4. So this is going to get me 3a to the negative 5 plus 2 is going to get me negative 3. b to the negative 5 over 5. And then negative exponents, I can move to the bottom and make them positive. So I get 3 over 5a to the 3rd times b to the 5th. All right, 2 more examples in this lesson. Again, I mention every time, you don't want to do too many things at once. You want to take it one step at a time. What I like to follow is just the order of operations, right? Do your PEMDAS. See if there's anything on the inside of the parentheses that you can simplify before you decide to work on the outside. All right, so if you look at 17, let's check the inside. If I do coefficient with the coefficient, that doesn't simplify, right? But I can do a with the a. I can move that a to the top. So I can do negative 3a times a to the 3rd. And then I can do b to the 1st minus b to the 4th. I'm sorry, b to the 1st minus 4. So I'm just using my exponent rules. This is going to get me a to the 1st times a to the 3rd, which is a to the 4th. So I get a negative 3a to the 4th, b to the negative 3 over 4 to the negative 2. And then that b to the negative 3 I can move to the bottom. All right, so let's work on the inside before we continue So I get 3a to the fourth, or negative 3a to the fourth over 4b to the third to the power of negative 2. All right, now from here you have options. Again, you always have options. You just don't want to break any rules of math. You could try to switch the top and the bottom and make that minus a plus, right? That's what I like to do, and then distribute. So I'm going to get 4b to the third over negative 3a to the fourth to the power of positive 2. And now that 2 I can distribute to every single factor. All right, I like to do that because I don't like distributing the negative exponent and then having to simplify more of it. I would rather just simplify all of your negative exponents right away. So I get 4 to the second, b to the third to the second, over negative 3 to the second, a to the fourth to the second. And 4 to the second is 16. Power to a power u multiply, I get b to the 6. Negative 3 squared is 9. Power to a power u multiply, I get a to the 8th. And that is fully simplified. There's nothing else we can do to that. All right, so again, always take it one step at a time. Same exact thing with the next one. I would do order of operations again, right? You can choose whatever order you want to do it in as long as it's something manageable that you're able to do, all right? So in the inside of my parentheses, I can do negative 3 and 9 to get me a negative 1 over 3. X and X cancel out. You could do your rule of exponents, or you can just recognize the same exact factor on the top and the bottom completely cancel out. And then I can move negative exponents accordingly. So then this is going to get me z to the first over y to the positive 2. And that's all to the power of negative 3. And again, I can switch these and make my negative exponent a positive. And this is going to get me 3y to the second over negative 1z to the first to the positive 3. And now I can take that exponent and distribute it to everything on the inside. All right, so this is going to get me 3 to the third, y to the second to the third, negative 1 to the third, and z to the first to the third. So then this is going to get me 27 y to the 6 over negative 1 z to the positive 3. And that's fine as is. Now, just a note, your negative can be down here, right? It can be on the side like that, or it can be in front of that 27. It doesn't really matter as long as you don't have two negatives, right? If I have something like that, that would be wrong because negative divided by negative is positive. You want to preserve the sign, all right? So no matter which way that you choose to do it, you should get this same answer. And that's as hard as they get. Take it one step at a time, and it should be fine. All right, and then we'll start the next lesson, next video.